Hello and welcome to another MSDP tutorial video. In today's video, we're going to be spotlighting the LFO Automator and the Signal Automator, and we're going to use these to create audio signal automation of parameters in other MSDP modules. For today's setup, I'm capturing my webcam feed and sending that first through a bit crusher effect, which we can see there, and then on into the scanline effect, where we're adding additional distortion and noise to the signal. On the left of the projector screen, we can see that I have the LFO Automator pulled up from the data menu. And below that, I have a Signal Automator pulled up, also from the data menu. Both of these modules allow us to control parameters, be they dials or input boxes, using audio signals. The LFO Automator synchronizes audio signals from the master metronome. So we can see that we have an LFO running right now, and it is going as a sine wave up and down at the rate of eighth notes as determined by the console's metronome. Below that we have a Signal Automator, which is going to take a signal in from this stochastic granulator when we get to this later. So both of these allow us a different approach to audio-reactive and synchronized sound. The top one will allow us to synchronize events to time, while the bottom one will allow us to synchronize events to the signals of other effects and processes. So I'm going to start by looking at the LFO Automator. As we can see, we have the ability to run up to 3 LFOs simultaneously. Although we won't see all of them right away, we can view any one of them individually. Right now they look pretty similar, or any combination of these, but this is just for viewing purposes. Let's look at what we can do to control each of these LFOs very quickly. First we have the LFO Toggle, which can turn these on and off. Next to that we can determine the shape of that LFO. It's a sine wave by default, but we have a variety of different waveforms that will give us different results in the end. For today's demonstration, I'm going to leave this on a sine wave. The next column allows us to determine whether we want to synchronize to the global metronome, that's the global value, or to synchronize to a local custom metronome, which we can see down here at the bottom of the module. Let's synchronize to the global metronome today. Next, we can choose the subdivision of that synchronization. Right now, we're running at the speed of eighth notes, which is pretty quick. You might want to slow that down, say to quarter notes. And then finally, we can determine the depth of that modulation. So at a depth of 1, we get values that range all the way between 0 and 1. But as we scale that value down, those values start to waver more close to the 0 line. So what we want to do is we want to use this undulating waveform to control parameters in one of these two modules. And what I'm going to do is I'm going to synchronize this LFO to the horizontal and vertical values in our video bit crusher. This first tab, the LFO Design Tab, is only used for setting up the LFOs that we're going to use. We want to go over to the Control tab, where we can then map the parameters of the LFO onto a parameter in another module. So you can see that we can map up to 5 destination parameters from the Control tab. Of course, if we wanted to use more than 3 LFOs or more than 5 control parameters, we can always just generate more LFO Automator modules. But this will be more than enough for today's demonstration. So the columns here allow us to determine which LFO we're going to use, and then we can determine what module we want to set, the parameter number we want to set for that module, a low and high value for those parameters. Then we can determine the type of data, whether it's integer or floating point, and then the rate at which those values are created. So let's go through each of those now by actually demonstrating this and mapping our LFO1 onto the horizontal values for that bit crusher. So first we need to know the destination module ID, which we have at the top right of every module that we create. Remember that the ID is initially generated as a random value, but we can always reassign this. So I might just recall this bit crush, make it a little simpler. we want to take the idea of that module and place that into the destination module ID text box in the Control tab. So I'm just going to copy paste that. Next, we want to make sure that we've selected the appropriate parameter. As we know, every module's parameters have numbers associated with them. If I want to use the horizontal bit crushing dial, I need to look for the parameter value associated with that, which I can see is the value 6. So back in the LFO tab, I'm going to set parameter 6 as my value. And for today, I want to map this to modulate between values of 0.2, which is pretty lo-fi, and 0.5, where you can see me a little bit better. So our low value is 0.2, and the high value I'm going to bring back to 0.5. Since both of these are floating point values, that means they have numbers to the right of the decimal point, we want to make sure that we're using floating point values for our output. Otherwise, as integers, those will both be truncated to 0 to 0, which is not very useful to us. Now, the rate determines how often values get updated on our dial. And I found that a rate of 20 feels pretty fluid. So at this point, as soon as we select which LFO or LFO combination we want to use, we'll start to see the results on our projector and on our bit crushing module. So let's switch that on now, and we can watch that running. Now, if we look at the changes in this module and compare it to the metronome, we can see that these are in sync. This dial is moving at the speed of once through its cycle per quarter note. If I wanted to slow that down, or speed that up for that matter, I can go back to the Design tab, and on the subdivision for the LFO toggle, I can choose a different value. At the value of a half note, this feels much calmer, and at a whole note, this will be calmer still. If we wanted to go a little wilder, we could bump that up to 16th notes, and we can see that feels pretty frantic at that point. I'm pretty fond of the half note value, so let's leave it at that. Now, along with the horizontal value, we can also modify the vertical value, the vertical bit crushing. We can use the same LFO, or if we wanted to, we could turn on a second LFO and use different parameters. I'm going to view that second LFO now, and I will choose a different waveform. The electric piano waveform looks pretty similar to a sine wave, but it has more complexity to it. I'm also going to choose a different time duration. I'm going to let this one unfold over the duration of a whole note. And now back in the Control tab, let's choose that vertical value for our second parameter change. So this is parameter 7, which we're going to place into the second column, but we do want to make sure we have the correct destination ID at first. So I'm going to copy paste that into the second destination value, and then I'll set parameter 7. Now I want to use the same range, 0.2 to 0.5, but I just want to demonstrate that it actually can be mapped with the higher value first and the lower value second. This will just change the phase, more or less, for this parameter change. So that will start actually at the quote-unquote low value of 0.5, and then we'll ramp to the quote-unquote high value of 0.2. So now I'm just going to switch on the second LFO, and we'll start to see that vertical knob moving in sync with LFO 2. If we wanted to, we could also sync this to LFO 1, and now we can more accurately see that these two dials are actually moving in sort of opposite phase of each other. Okay, next I want to demonstrate the Signal Automator and how we can use signals from either our inputs, our microphones, our instruments, or from instruments that are inside of MSDP. For today's example, I'm going to be using the stochastic grains instrument that we saw in the Getting Started tutorial series. And just so we can hear for a moment what it is we're going to be working with, I'm going to turn on that effect now. A nice, calm sort of sound, right? Now, say we want to use that waveform to control something like the distortion value on the noise tab of the scanner module. We can see that with a very high distortion value, we get these wild and rapidly shifting streaks in the waveform. So that's a pretty high value. I've actually gone much farther than the dial allows. Remember that we can always go outside of the parameters limitation set by the dial by simply clicking on the number below the dial and then either dragging it up or down with your mouse or typing in a number on your keyboard. So for this demonstration, I want to try a rather large range. I want, when we are sitting in silence, to have no distortion from the scanner. And when we are at full amplitude, I want to set that to a distortion value of 200, or maybe even larger than that, maybe something like 1,000, so that we can see a large change. I'm going to go ahead and start the granulator again, and then I will leave that signal in the background so I can speak over it. We can hear that I've set this instrument to an interval of 1/8 notes, but a duration of only 1/16 notes, and I'm going to pull that back even further. What this does is it gives us these fast spikes where we have a lot of volume, and then a lot of silence. This will allow us to see the connection between the granular synthesis and the signal automation. So the Signal Automator works very similarly to the LFO Automator, but instead of expecting a signal that's already in the module, it's going to ask us for a signal from somewhere else in our project chain. So if I synchronize the input to this first signal in strip with one of the outputs from the stochastic grains, we can start to have this share information. Remember that you can select any input-output combination and it'll work fine. So I'm going to set this output and this input to A1. And right away we can see those rapid pops and the long silences afterwards. Now that we've synchronized these two modules and we can see the output from them, let's do the final step in the Control tab of wrapping that information or mapping that information onto the parameter that we have over here. As always, we need to grab that parameter's or that module's destination ID. For simplicity's sake, I'm just going to rename this scanner. And then I will copy-paste that into the first row of our control mapping. Now from here, this is very, very similar to what we saw in the LFO tab, with the one difference being that instead of selecting an LFO, we're selecting one of these signals. I can see over here that distortion is parameter 14, so I'm going to set that in. I still want that low value of 0, but the high value is going to be 1,000. Now we can see that with 4 values, it's not properly displaying in the module, but that value is there and it is properly set. Finally, all I need to do to get this started is select that signal from the drop-down list. And we can see that these changes are happening very rapidly now, right? Because we have that very, very fast pop. So let's see if I can increase the time of that pop so that these changes aren't so rapid. I'll set that duration to 16th notes. That feels a little bit better now. We can see that we have these drastic shifts happening, and they are huge, right? But they're happening a little more smoothly because we actually have a longer signal to work with. If I slowed down the playback of these notes even further, set those to quarter notes, and then set the duration to something like dotted eighth notes, now we can see those big pops happening a little more gradually still. And we have a very attractive and very interesting audio-reactive video sequence for our performance. That wraps up today's tutorial. Thank you for watching, and we'll be back soon with more videos.